Hello everyone. So yes, I discovered AWS before OpenBSD. I'm very new to OpenBSD, and this is going to be part of the talk I'm going to give today. Come in. So first of all, a very quick introduction. So my name is Laurent Bernaille, and I work at a small consulting company called D2SI. I've got mostly a Linux background, and I'm just getting to know OpenBSD. I've been working on cloud projects for the last 5 years or something, and I really like it. And I really love discovering, building, and breaking new things, and I really enjoyed discovering OpenBSD. So what you can expect from this talk is on this slide. So the first thing I'm going to talk about is how OpenBSD came to be on AWS and how it's integrated with it. And then we'll talk about, and we'll do a demo, which hopefully is going to work, but it's a demo, so we'll see. And how we can use OpenBSD to do microservices, and I'll give you an example of how we can build dynamic VPNs using a tool like Console, and all this on OpenBSD. And finally, like throughout the talk, I'm going to give you my feeling with OpenBSD, and I can already tell you that it's been very good, and I've been very impressed by this operating system. So first is, well, how OpenBSD came to be on AWS. So it all started when... Okay. Yeah. Sorry? It's... Yeah, pas de son. Do you want me to talk louder? I can talk louder. Oh, okay. Come on in. Okay, so the whole story... So the whole story of OpenBSD and AWS started in 2015 when Antoine Jacoutot, who most of you know, I assume, started working at D2SI with us. And at that moment, we were already working a lot on AWS. And when Antoine didn't know AWS very well at the time, and he checked if OpenBSD was working on AWS, and it wasn't. So most Linux distributions were already available on AWS, and FreeBSD was also available, but OpenBSD was not there. So he took up the challenge to create an image for OpenBSD on AWS, and it proved to be quite a challenge because, well, it was... he made an image quite fast at the beginning, but then discovered that due to lack of Xen support, many things were not working. So the instance was booting, but there was no network support at the beginning. So thanks to a lot of work by Mike at SSH, all this Xen support has been progressing over time. And so basically, like beginning of 2016, there was the first OpenBSD image working on AWS. If you're interested in all this story, you can have a look at all these links I put on the slides. So the first one is like an introduction of how the first image was built. The second one is the GitHub repository where you have the code on how to build the actual image on AWS. And the last one is by Mike, and it's explaining how he worked on Xen support for OpenBSD. So yes, so the first image worked when the network was fixed, and the second issue was disk. So at the beginning, OpenBSD was using IDE fallback for disk support, so it was okay for the root disk, but if we're adding additional disk on AWS, it was not working. So like mid-2016, this was okay, it was fixed. We had a big surprise at the end of 2016 when suddenly some OpenBSD machines were not starting. So when we were starting an instance on AWS with the same image, in some cases it was not working. So it was like very surprising. And what was happening is actually AWS did a change in the hypervisor, and some primitive from Xen were not supported. So this was fixed in probably January 2017. And so it was all this fix is available since 6.1. And so the picture I put there on the right is at the time of the first patch for this issue, we're actually working for a customer in Monaco with Antoine, and he received an email from Mike telling him, like, I have a patch available, can you test it? And we're at the bar, so we're drinking, and so we were discussing, and suddenly, like, Antoine, like, couldn't take it anymore. He took up his laptop, patched it, applied the patch, and tested it live in this bar. So this is what this picture is. And you can see, like, traces of pizza on the table. So all the demo I'm going to show you is going to be based on 6.1. And you can expect many more performance improvements in 6.2, so very soon. So let's have a look. So I'm going to start an OpenBSD machine on AWS. So it's going to be hard typing with the mic. I'm going to do my best. So I don't know if most of you have already seen the AWS console. So this is like the console where you get to in AWS, where you want to create instances. And so what I'm going to do now is I'm going to create an OpenBSD instance. So I'm just going to look for OpenBSD. Okay, and I'm going to get the latest image here. And I'm going to start it. So I won't touch most of the options. I'm just going to give it a tag, so we know what it is. Okay. Then I need to be able to access the machine. So what I'm going to do is I'm going to create a security group, which is, for people not familiar with AWS, a firewall in the hypervisor of AWS to filter traffic. So let's call it SSH Demo. Okay, typing with one hand is definitely going to be tricky. And what I can do is I can even say, okay, only my IP, so people won't be able to connect to it. And so now it's starting. So what's important, and we're going to deep dive into this just later, is it's asking me for a key pair, so a public key that's going to be put in the authorized key file on the machine so I can connect to it. So the machine is starting. It's going to take about probably like 1 minute. So you can see here my machine is starting. Okay. And we will be able to connect to it in about a minute. So as you can see, like we have several information on the machine. Like it's been given a public IP address I can connect to. It also has a private IP address, because what AWS does is all machines only have private IPs. But if machines are in public subnet, they have one-to-one NAT mapping with the public IP address. So we will be able to connect using this address. And then you have other things like instance type. So I chose a very small one. We don't need any more. And you also have like security group, which is the one I just created to allow only connection from the Wi-Fi IP address and on port 22. So let's try and connect to it. Okay, so here I'm connected with the user called EC2 user, which is standard on AWS, and I'm going to explain to you afterwards how it works. So as you can see, I'm just connected to the OpenBSD machine on 6.1, and that's it. So we have an OpenBSD machine inside AWS. So it's not very interesting, but we're going to dive into a few more things. So the first thing is, you saw that I put my public IP address, my public key, sorry, when I created the machine. And the question is, how can I connect to it? So, of course, I have my private key on my laptop, so that's why I was able to SSH. But how was the key downloaded to AWS? So the way this works is AWS exposes a metadata web server at this address there. And there are a lot of information, and we're going to go through a few ones afterwards. But the one we're interested in now is public key, which is like a directory where you can get the public key that you gave to the machine. So we're just going to check that. Okay, so as you can see, when I connected to this and with the same address I gave you, I can see this, and now I'm going to get the public key itself. Okay, so this is actually my public key. Okay, so it's available on the metadata server, and as you can see, if I look into my authorized key file, I have exactly the same keys there. Okay, so this is how this is the same key. So now the question is, how did the key get there? So this question is, how did it get configured, and how my candidate up there is actually interesting. Is to do this, most Linux distributions rely on a tool called Cloudinit. So I gave you the link there, and basically this tool is as its origin in Ubuntu Cloud. So they wrote it to configure machine when they were booting, and it became like a standard for most Linux distributions. So they almost all the one I know now use this Cloudinit. So Cloudinit does a lot of things, but it's a very big piece of software in Python, and is very Linux specific. So in order to have like a minimal Cloudinit implementation, Antoine wrote EC2 init there, and you can access also the repository here. And this tool is actually run when the machine is starting, and it's very early in the boot process because it started when the interface comes up. Okay, so we can have a quick look at this file. Okay, so you can tell when the interface comes up, it's configured using the HTTP, which is the normal way to do things in AWS, and then it's executing this script here, the one I was just talking about. Okay, so this script is not that long, but I won't go through it. I'm just going to give you a quick idea of what it does. Okay, so this is like, all these are the functions called by the script, and I'm going to go through it quite quickly. So the first thing is, since this script is run very early in the boot process, PF is not open. So the first thing the script does is it opens PF so we can connect to the metadata server. The second thing is, this script is run every time the machine is started, and we only want to configure it once, or at the first boot, basically when the instance is created. So the way this is achieved is, it's getting a metadata information, which instance ID, which is like the unique identifier of the machine inside AWS, and it's comparing it to a file there, so vardb ec2 init. And if it's different, it means like it's a new machine, okay? And if it's a new machine, we need to configure it. So the first thing it does, then it's actually creating the vardb ec2 init file. So it puts the instance ID there. So when we reboot, the script is going to fail it's going to stop at the first if. And then it's getting the public key. So this is how my public key got in there and how I connect it to the machine. It's configuring the host name of the machine based on AWS metadata, because when you create a machine in AWS, AWS gives it a default host name. So this way it's going to match. This function here is executing user data, which is another metadata information that AWS gives, and we're going to focus on that a little later. These last two, I'm going to first talk about this one, so this one is easier to understand. So sysclean is going to clean up the instance. So if you create an image from an existing OpenBSD installation, what's going to happen is you're going to have SSH key, logs, and DHCP leads, for instance. And this script is going to remove all that. So we start with a brand new machine. Okay? So then when this is done, the machine is going to boot. Since there is no SSH key, it's going to generate one. And what this script does here is going to write to RC first time, a very small script, to display the fingerprints of the SSH key. Because once again, it's a standard behavior for most AWS images, where at the end of the boot, you've got the fingerprints of the SSH key that have been generated for the machine. Another thing is, you remember when I connected, I used the EC2 user to connect to the machine. So this is like standard behavior on AWS. Well, basically, you never connect as root. So you use, there's no SSH key for root. And Amazon Linux is using EC2 user from the beginning. And most Linux distribution went the same way. So Red Hat, Fedora, or CentOS. And FreeBSD made the same choice. Debian and Ubuntu made different ones. So as you can see, the Debian default user is admin, and Ubuntu is Ubuntu. They never do anything like the others. And when I connect to the machine, this EC2 user has like unlimited DUAS access. So if we look at the configuration of DUAS, we can see that we have all permissions. Okay, so you can see that I can do anything with EC2 user, and I don't need to enter a password. So for instance, I could look at And so you see, when I display the image, I can see all the fingerprints from the machine from when it booted, so the one created by the script I showed you earlier. Okay, so now that we have an instance, we're going to try and do a few things with it. So the first thing we're going to do is we're going to install a tool called Terraform. And then we're going to clone a repository and do a few things with Terraform. So for those of you who do not know Terraform, it's a tool to describe cloud infrastructure components and build them in a repeatable way. So you can think of it as Puppet, but instead of configuring server or services inside server, it's going to configure infrastructure. So you have alternatives like CloudFormation, which is AWS specific, and HIT that was developed for OpenStack. But Terraform is getting to be like the standard for all these kind of things. It's supported also by GCP, by Azure, and by OpenStack now. So let's do this. Okay, so first I'm installing console, and now I'm going to install Git. Okay, and then I'm going to clone a repository where all the demo is, and everything is on GitHub, so you can have a look at it afterwards if you want. Okay, so in this repository we have several things. And the first thing I'm going to do is I'm going to build a VPC inside AWS, and I'm going to show you what it is. Since it's going to take about a minute, I'm going to start it. So, okay, okay, I didn't install Terraform, sorry. So thanks. Okay. I went too fast. I already installed console on this machine where I don't need it. So that's going to work a lot better now. It's very hard to type with the mic. Okay, I need something else. So this is interesting. So what's happening is I'm telling Terraform to do things, and I have no permission inside AWS to do it. So what I forgot to do is to update my credentials. So I'm to upload my credentials there. So I'm going to do it right now. Okay, so I'm using a profile here. So I have several identities inside my AWS credential file, so I'm telling the one I'm using. Okay, that should have worked a lot better. Okay, what happens? Oh yeah, I know what happens. Okay, I'm going too fast. Demo effects. So I forgot to create the .aws directory. So basically what I did is, instead of putting the file inside the .aws directory, I created a .aws file. So, sorry. Okay, we're there. Sorry for this. Well, and actually, this is not the real demo part because afterwards things might break. This is something that should have worked like from the beginning. Okay, so I just did Terraform plan, which is like telling me what Terraform is going to do. So it's telling me that it's going to create a whole bunch of resources, and I'm going to show what just afterwards. Okay, so I don't know if most of you have heard of Terraform, so I'm just going to give you a very quick introduction to what it looks like. So basically, on the black boxes here, you have description of resources inside AWS. So on the top, for instance, you have the description of the VPC, sorry, which is basically like a private subnet inside AWS, a dedicated subnet, a whole bunch of subnets, and inside this isolated network, you can create different resources, such as subnets, for instance. And this snippet here is creating a public subnet. So what's interesting is this resource is a subnet, and I call it public. And what's important here is I can give it a reference to another object that I've created before. So this VPC ID there is actually pointing to the VPCs that I've created before. So I can like dynamically get the ID of the object that was created. And Terraform is going to do a whole dependency graph, so all the resources are created in order. In addition to like networking things, I'm also creating a machine, so a Bastion host, where I'm going to SSH to connect to different machines. And like you have like different parameters for a machine, like the instance type, T2 micro, which is the same one than the machine I'm using right now. The AMI, which is the image I'm using, and here it's so the OpenBSD AMI. And in which subnet I'm going to create it, and so on. So if we're lucky, Terraform is going to have worked. Let's have a look at it. Okay, so it's still creating, but I can start showing you things. So I'm going to the VPC part of AWS. So I'm going to show you the VPC I'm creating. So let's filter on the new one. So it's this one called Demo EuroBSDcon. So this is this VPC with this address range. And I have like several subnets, like 3 public and 3 private subnets. Okay, and so everything is being configured right now. And so if you remember just before I showed you an example with only 4 subnets, because it was easier to fit on the slides. But what I'm going to do now is I'm going to show you what we're actually building. So this is what we're currently building now. So everything is almost ready. The only thing that's missing is the NAT gateway here. So you have 2 different kinds of subnets in AWS. Public ones, which are machines which have a public IP address, so you can directly connect to them. And private subnets, which are subnets where machines only have private IP addresses. So if these machines want to connect to the internet, they need to be NATed, and there's a service inside AWS to provide this NAT. So basically, any machine here would connect to the internet using this NAT gateway. And this is a little long to create, but it should be okay now. Yes, exactly. With the description I gave you, the examples, it's what's in the code there, actually. Okay, with like different thing because it's not the same kind of, exactly the same thing because it's different subnets, but it's exactly the idea. So it's a language that describes what you want inside AWS, and then it's going to create them inside AWS.
And Puppet, you mentioned Puppet. How is it created?
Oh, it's similar, like what we, yeah, exactly. Okay, so everything is done. So this is all the objects that were created. Okay. And I can connect to this new Bastion machine here. And here we go. Okay, I'm connected on the new machine. So this is the first machine here. So I can show you its IP address. So the one from which I'm running Terraform. Okay, and this is the new one. Okay. Okay, so this one is in the address that I just showed you on the slides. Okay, so Now what we're going to do is we're going to start creating more interesting things. Okay, so we had like the basics, so all the network basics, and what we're going to do now is we're going to build a console cluster. So console is a tool developed by HashiCorp, so the people who do Vagrant, Packer, and Terraform, and it's used for service discovery, and it's a distributed key value store. So in our case, this cluster is going to be made of 3 machines there, which are console servers, so servers that participate in the Raft distributing consensus and that store data. And this one is just a client of the console cluster, so it's part of the cluster, but it's not going to store any actual data and not participate in any master election. And I'm just using it to connect to the UI, so I can give you like a graphical version of what's happening. And let's do that. Okay, so now I'm using another Terraform script. It's similar to the one before, but instead of creating network resources, it's going to create machines, like the 4 machines I just showed you, to build the console cluster. So it's going to take probably like a minute. Okay, so this is, this is a slide of, but I already told all this. What's important with console is it's used a lot in microservices because it allows service discovery. So basically, machines or containers can register themselves as providing a service, and then you can use console as a DNS to connect to these machines. It also provides a key value store, so you can store configuration, and you can have your application get that data from console and get configuration from there. What's important is it's very resilient. It's been tested a lot for resiliency, and that's why there's this Raft implementation for to make sure that there's data is always consistent. There's always a master, and if one node were to go down, everything would still be okay. So let's see if it's up now. Okay, so as you can see there, it's up. Okay, we're going to have a quick look at it. So I'm going to, as you remember, all these machines have only private IP addresses, so I need to connect to this one through this one. So I'm just going to do that. So this is the console UI. So the cluster has been built. And as you can see, console has identified 4 nodes. So 3 console nodes where there's one service, which is the console service itself, and 1 console agent where there's no service. It's only a client on the cluster. And so this is the view we have, the UI from console, but we can also check it from the machine itself. So I'm going to connect to one of the console servers and show you that. Console is not AWS specific. It could run anywhere. And Terraform also can drive AWS, GCP, Azure, OpenStack, and many more.
So it's not specific to the
No. I mean, the AWS support is very important because it's how they started. But there's a very big community and many people like working on it. So let's connect to one of the servers. Okay. And I can see here exactly the same information we had on the UI. Okay. So on this server, we have console installed and the agent. So now, I mean, you remember I told you, like, I started a standard OpenBSD machine and I have console installed. So how did that happen? Okay, so this we did. So you see that all these machines are configured and we have a console cluster. But with the AMI, so the image I used when I started the cluster is a standard OpenBSD machine with nothing installed in there. So of course console is not installed there. So the way this works is with the user data I mentioned before. So it's a script that you can provide when you create an AWS machine that's going to be available on the metadata server, and that is going to be run by Cloudinit, or in our case, EC2 init. And it provides you a way to bootstrap the machine and install a whole bunch of stuff and do configuration if you want. Yeah, you could. And actually, one of the reasons Cloudinit is so big is because you can have direct Puppet primitive in there, for instance. So you could do a Puppet run here, for instance. In my case, what I want to do is very simple, so I don't need Puppet, but you could definitely do it with Puppet if you want. So what I do is basically I install console, and then I do the console configuration. So I'm not going to go into too much detail, but basically this part here is telling console that this is a server. Okay. So remember, there's two distinct nodes in console, servers and clients. And so this one is a server, and this one, the bootstrap expect, is telling like, don't bootstrap any cluster while you don't have at least 3 members. Okay. So because if you don't have anything like this in there, when the server is going to start, it's going to start in standalone mode, and you wouldn't have any resiliency. In our case, we want some, so we tell console like start with 3 nodes at least. Sorry? Yes, exactly. But I think like if console server is by itself, it's going to establish core run for 1. Okay? So that's why I'm telling it, well, don't start anything before you at least 3. And the thing is, like, it needs to discover the host, okay? Because all the 3 console servers are going to install console and start with this configuration. But the thing is, they need to find the other ones to build the cluster and build the quorum. And the way it's done is you have different discovery mechanism. And the one I use here is integration they did with AWS, which is it's trying to discover other members from the cluster by using AWS API. So what console is going to do is going to describe all instances, and it's going to have all instances. It's going to try to connect to all instances with this specific tag here. Okay, so a tag called console cluster with value console, and I'm going to show you in the AWS console how it looks afterwards. And then, well, we need to enable the console service. So if we reboot the machine, console is going to start. And then there's a small workaround I had to do to get console to start at first boot. Is since I enabled console very early in the boot process. It's done by when the interface is coming up. So it's enabled, so it's going to be written, this is going to be written to rc.conf.local. But the thing is, this file is parsed earlier only once in the boot process. So basically, console is going to be appended to pkg scripts to be started. But since it's not going to be reread afterwards, console would not start. Okay, so to have it start, what I did is I write to rc first time, start console. Okay, so this way it's going to start. That afterwards. Here on the console, the few things I told you. So we have now we have many more instances than before because we have the 4 new ones, the console ones. And if I click on this here, I can show you that there's a tag, and this is how all the console servers are finding each other. And also, so I won't dive deep into it, but the machines needs to have permissions to call the AWS API. So the machine have a role which allows them to do a describe instance, so basically list all the instances with a given tag. Okay? And if you have a question about this, we can discuss it afterwards. So now that we have this console cluster, well, what are we going to do with it? So there are many things you can do with console, I was saying before. But in our case, we're going to use something that's pretty simple. We're going to use a companion to the console that's called console template. And what console template does is it connects to console and watch for keys in console. And when they change, it can generate a template. It can generate a file from a template, and it can execute a script, like a reload of configuration, for instance. So what we're going to do with this is we're going to build a dynamic VPN gateway. So what we want to achieve is to have a generic VPN machine without any configuration. And what we could do is put the configuration we need, like endpoint, pre-shared key, and all this inside console. And then it's going to build the configuration and start the VPN. Okay, so let's do that. So I'm using Terraform again to build this machine. It's quite a simple Terraform script, but it's easy while it's building, so this is where we were before, and I'm building this new machine here, okay? And this new machine is going to be the machine which we are going to use to build the VPN, okay? So it's going to be ready in a few seconds, and we can have a look at it. So what we're going to do just afterwards is we're actually going to connect. Sorry, I'll go back to that afterwards. It's just to win some time. So what we're going to do is going to be this, okay? So I'm going to start a machine inside another AWS region in the US. Okay, this is the one called Demo there, and I'm going to build a VPN towards this machine. I'm going to be between this machine here and the region in the Virginia region of AWS. I'm not going to build a VPN between my OpenBSD machine inside Ireland and another OpenBSD machine inside Virginia. What I'm going to do is I'm going to use the native AWS VPN service, which is called Virtual Gateway in AWS. So basically AWS has a VPN service, and what I'm going to do is I'm going to connect my machine to this VPN service, and then I'm going to try and ping the demo server inside this VPC in Ireland. So let's just go back to the machine and see where it is. So the machine has been created. I can now connect to it. Okay, here we go. And we can check that IPsec has been enabled. So well, there's no IPsec.conf configuration yet because I haven't done anything with the machine. If I look at IPsec.ctl and list all the flows, okay, so there's no flow, there's nothing. I mean, IPsec is enabled, but there's nothing in there. And the thing is, you remember before we installed console using user data, and this time we did a few more things. So let's have a look at this. Okay, so this VPN server, what we did is we enabled IPsec, which is what I just showed you. Okay, here, and then we installed console. And we installed this new tool I was telling you about, which is console template, which is going to connect to console and get data from there. So we're installing the console template package, and we're configuring it. Okay, so we're telling it to connect to the local console agent. Okay, so we install also a console agent on the VPN machine. And then there's this template configuration, which is basically, well, I have an IPsec template file. Okay, you're going to use this template, and when you have keys inside console that matches this template, you're going to generate this IPsec.conf file. Okay, and when the file changes, what you're going to do is you're going to run this command, which is going to reload the IPsec configuration. And here is the template here. So I want so the way the template works, it's basically I'm going to create keys inside console that are going to look this way. Okay, so I'm going to have a root key called VPN, and then like a description for the VPN endpoint I want to connect to, and then I have 3 subkeys which have all the configuration I need to build the IPsec configuration. And so that's basically the network I want to connect to, the endpoint, which is the IP address of the machine I want to go to, and the preset key I want to use. So basically from this in console, we're going to try and generate this configuration in IPsec.conf. And the way this is done with console template is with this, I mean, frankly, awful templated language, which is derived from Go template. And what it does is it's going to iterate over all subkeys inside VPN. So this is the first line. It's going to check if these variables are not empty, because I wouldn't want to create an invalid IPsec configuration. So it's like basic sanitation. I don't want this variable to be empty. And then it's going to generate this this code inside the IPsec.conf file. Okay. So let's go back to the machine. We can check that console and console template are started. Both services have been installed by, and they're working. And also IPsec I just showed you before. Okay. So let's. what I'm going to do now is I'm going to create the machine inside the other region so we can check that we can actually build the VPN. So I'm going to go to Virginia, here. Okay. And I'm going to create a new machine. So it's also going to be an OpenBSD machine. Let's do that. That's not going to work. Okay, so this one is a copy of the latest machine. Let's start it. Okay. No, there's, okay, so let's call it, let's give it a name. Is it okay? Sorry for the guys listening. And what I'm going to do is I'm going to allow only ICMP from my current network. Okay. So ICMP, and only from the 10. So the network I have here. Okay. So that should work. Okay. So the instance is starting. So this is a new machine that's this one is in the US. And what I was telling you before is we're going to build a VPN with connected to the AWS service inside for the VPN service inside AWS. So it's configured here. Okay, so this is like the VPN gateway from AWS. It has been created. And the reason I created it before for the demo is building this service and configuring it is taking like at least 5 to 10 minutes. So for a demo, it's kind of long. And so this endpoint here is the public IP address of my machine, so my VPN machine. And the way I did that to make sure that this address is not going to change and that my VPN is going to come up is I use a concept called an elastic IP inside AWS. So basically, when I started the VPN machine, instead of letting AWS pick a random public IP, I told him, like, use this one that I've reserved already. And then there's this VPN connection. Okay. So this is a VPN connection. And if we look at the details, well, there are 2 endpoints inside AWS, which both with these 2 IP addresses. And the tunnel is done, of course, because I mean there's nothing configured on my side. Okay, so what I'm going to do is I'm going to get the configuration, and I'm going to input it inside console. So let's go there. Okay, so this is the configuration for the VPN. So you have like configuration for different equipment, but I'm just interested in the pre-shared key, the IP of the endpoint, and I already know the network. Okay, so. I mean, you remember, when I go to the machine, there's nothing in ipsec.conf. We can go, you remember? There's nothing in there. And what I'm going to do now is I'm going to put the necessary information in console to get this generated. So I'm going to mirror the organization I showed you before. And I'm going to create the CIDR block key. So my VPN is so this is the IP address range in the US. Okay, I'm going to add the endpoint, which is the IP address I need to connect to. So it's somewhere in there. Okay. And I also need the pre-shared key. Oh, thanks. Okay, so I've put all the necessary information inside console, and if now I look, oh, thanks. Machine. Okay. You can see that I've got this loaded IPsec configuration. Okay. I'm gonna need its IP address. Thank you. So it's working? Okay, so this is the part of the demo that where it may not work. Let's see. So I'm taking the IP address of the machine that has been created. So it's really its private IP address inside AWS, and I'm going to try and ping it. Okay, cool. That worked. Okay, that was lucky. Yeah, I mean, of course, like all the time when you repeat, it works. But when you do demo, it's kind of thing like you have so many things, that's so many moving parts. And so if I look at the IPsec flows, so IPsec CTL. Okay, you can see that my all the flows have been created with AWS. So we're done for the demo part. Let's go back there. So this we did. Okay, and so we're done. Like I'm a little late. So okay. So just like at the conclusion, what I wanted to do a few things. I mean, one of the reasons I think OpenBSD is very interesting for this kind of service, it's like it's basic infrastructure service that's going to be core in your infrastructure when you start using it. So using a simple and very secure operating system is very important. So I think OpenBSD is a very good choice for this kind of use case. And in my demo, there are many things that could be improved in terms of security. I mean, I did it in a very simple way, so it's already a little long. So in console, you can enable SSL. In my case, there's no SSL communication. You can also have ACL. So you can limit, you can give tokens to people for certain set of keys and limit access to certain keys because you wouldn't want anyone with access to console to be able to reconfigure your VPN. And also, you saw that I put the pre-shared key inside console. Since it's a secret, it might be better if it was encrypted even at rest. And so there are other tools you could use for encryption, and there's actually a tool also built by the people that do Terraform and console, which is called Vault, which can be used to store like secrets. And Vault also works on OpenBSD, by the way. So my use of OpenBSD is very recent, but I've used it in several use cases, like VPN gateways, I've just showed you, DNS proxies, or DNS resolvers, and now console. Of course, there are many more use cases. What I've found interesting, and this is also a discussion I had with Antoine when he told me to propose a talk for here, was like it's interesting to see OpenBSD used for microservices kind of workloads because we can see that it can be used for these things for today. All the code for the demo is available on GitHub. If you have any question afterwards, you can ping me on Twitter, no problem. And if you have questions now, I mean, we have a few minutes for it.
Thanks very much for this presentation. So that's a lot of automation in there already, but there are some parts missing a glue. Like you have the Terraform stuff, building everything automatically, and then you have to create the VPC manually in your case and looking up the IP address from the Elastic IP, add that to console manually again. Question is, did you try to have something like Ansible modules creating the VPC? They are available, but then retrieving the IP information and putting it into console via Ansible or whatever, or Puppet or...
So the thing is, like the Terraform part, I mean, actually Terraform is, you can compare it to, Terraform and Ansible can be compared. I mean, Ansible is mostly focused for what's happening inside servers, even if it now has modules to be able to manage AWS. I think like for managing cloud objects, Terraform is better than Ansible. One of the main reasons for this is Terraform maintains the state of all the resources it creates. So if you remove something from your Terraform file, it's going to be destroyed. Whereas from Ansible, it's easy to deploy, but when you want to remove things, you need to have new playbooks. So it's actually very, you can use Terraform for the whole infrastructure part, like VPCs and all these things. And you could use Ansible to configure the machines themselves. And you said like the build of the VPC was actually automated. It's the first Terraform run I did. I built the VPC automatically with Terraform.
More questions? Was it the same question several times? I saw more hands previously.
I just wanted to know whether the sheets will be
The slides? Yeah, sure.
Yes.
Ah, where? I don't know. I mean, I don't know if there's something that's already prepared by the conference. Otherwise, I'll put them on SlideShare. No problem.
So just get a fake LinkedIn account and you can go to SlideShare afterwards.
Yeah, and the repo is there for the code, but there's no slide. That's what I'll do is I'll put a link to the slides on the repo.
What's the state of Amazon supporting OpenBSD officially?
Well, today there's no official AMI. I know it's a trick question. Maybe Antoine, you're better placed to answer this. AWS is interested in having official support, but it's not done yet. But the AMI there is working very perfectly. I mean.
Any other questions? Well, let's thank Laurent once again.